everyone. It's really a pleasure for me to be here. And on behalf of Karim and Zohra, we're really happy to attend this session of Africa Arena. Instadeep in few words, and I'm not going to show any slides about Instadeep. This is not the purpose of my talk today. But what I can say is Instadeep was a lot of hard work, a lot of difficulties and challenges, and few successes, but very good successes at some point. So I joined Instadeep almost 5 years ago, but the journey started 10 years ago with Karim and Zohra, and Sabrine was one of the first employees at Instadeep. And what I've heard from them is that it was always about trying, hardworking all the time, and keep positive and optimistic vibes. Are the slides ready? Nothing? Okay, let me just check that I can do this properly or not. Okay. Wow, it works. Amazing. Almost there. We can use AI for this. Amazing, amazing. I think I deserve my PhD. So my talk is beyond even Africa. We believe that we are at a moment of AI where it's really important to have a pause and to look to what we think is coming next. And this is why we really believe that the future of AI is going to not only change the world, but not only Africa, not only Tunisia, but also our lives. So I'll take you to some what we believe are exciting things, maybe less exciting than a Hammamet weekend, but I'll try to make it as fun as possible. So, yeah, great. So my summary is, we know how AI is growing fast, so I'll go quickly on that and I'll explain why, and why we believe that there is a real super cycle behind that we are currently witnessing it. And what we expect is the future, and to conclude is how an AI company or an AI first company should be aware of. Okay, so the AI growth is based on 3 main pillars. There are 3 things that are making this growth not exponential, but triple exponential. And I'll show a graph later about what we mean by exponential, because it's not something that naturally, as a human being, we understand. We always believe on a linear basis, linear scale. Exponentiality is not very intuitive for us. So when I go to exponentiality and why I say 3 times, it's because we all know how much data is now collected, created on the net. And this is all is known with all the internet explosion of the last 10 years. But also the compute. So every 1 or 2 years, we have much more efficient compute systems coming from NVIDIA and others that allow us to, with the same, maybe to have the same accuracy of our models, but with much less compute needed. And the third part of the exponentiality equation is the models. So even if the very beginning of deep learning models existed 50 or 60 years ago, however, the more we are improving and with the more we get better results, the more models are improved also by the same time. It just takes some time. There we go. So if I look to the hardware side, we all know about the Moore's law. So the Moore's law is just saying that every 2 years, we expect that the compute systems just doubles. And this is still valid right now, and it's even more, let's say, happening, or we're witnessing this for ML, because we believe that the ML systems in itself, so the whole model and hardware and also the data, will probably also increase by 1 million x in the next 10 years. So we're talking about a huge, huge increase in the efficiency. And whatever we're witnessing in terms of improvement in the computer systems and hardware that we see are just proving that the Moore's law we're following it and even faster than what we expect. Just maybe pause. Where should I just direct here? No, ça marche pas. Cool, here we go. The second part of the exponentiality is the model. So here what you can see, maybe you can see it on the down, is this time scale. So here it's for 2020. And here it's how many basically compute we needed to get to a good accuracy of some models. And what we see is that right now, every 16 to 18 months, means every 1 year and a half, we are able to have the exact same accuracy of our models, but with exactly half of the compute. Means if today you have to use maybe a graphic card that costs $10,000, in 1 year and a half, you only need one that costs $5,000. And this is happening for the last few years. So in addition to having more hardware, more efficient hardware, you have better models, you have much more data, but you're also getting more and more, let's say, less cost for this accuracy of our models. So with those three type of, let's say, explosion or improvement that we see for the AI model, what is happening right now is that the AI, let's say, trend is not only improving or progressing, but it's really going through a cycle that is, we believe, as a super cycle. So just, yeah. And here I'm going to pause and go back to this exponential point. So usually when we progress, and we are right here, whenever we think about the future, we really usually think about it on a linear basis, means it will improve. But we have difficulty to see it as an exponential way. And I'll give you a very concrete example of something that happened in an exponential manner that we just all lived or went through the last 2 years. And it's about COVID. So COVID, the pandemic, really explodes on an exponential manner. But we couldn't imagine this when we were at the middle or at the very beginning. It was probably, yes, going and growing, the numbers were growing. But then at some point, we were not able to imagine how much was this growth from a day to another. What we're witnessing in AI, it's exactly the same trend. This exponentiality, we are witnessing that there are breakthroughs. Whatever we're showing right here basically wouldn't happen if there was no ChatGPT, for example, in late November 2022. And since 2022, there's so many breakthroughs every week. We're not talking about every month, but every week. And this is exactly the feeling that we get when we are within an exponential trend. So right now, we're really here. And we believe, with all the numbers and the metrics and the breakthrough that we see, that we're going through an exponential cycle. The other addition to this, so not only we have more models or better models, more compute, more data, but there is another factor that comes to this. It's AI itself. So now, not only all this is improving, but AI itself is also improving what exists already. And this is, it's adding more to the exponentiality that we have seen. One of the examples is about the data. So whoever does ML projects or ML work knows that 80% of your time, or the ML engineer, is about data. How to collect the data, how to label it, how to clean it, how to process it, and so on. And this is 80 to 90% of the time. Now, if we look to how ChatGPT in orange or ChatGPT in red, how good and how fast they are able to annotate the text, means they label the data, compared to human approach, like Mechanical Turk or trained annotators, we see that we're basically, this big piece of work that we do for ML is now 20 times faster and cheaper. So without also any human intervention. So it means it's consistently faster and consistently cheaper than what we were doing so far. So, as I said, when AI is feeding this super cycle, it's feeding it by reducing the time we spend when we annotate and we create the data, but it's also feeding or improving the way we are coding itself. So when we have assistant like Copilot, which is an AI assistant, or GPT-4, where whenever you need to code, you just may mention what you would like to code and you have the code there. This basically reduces the time and the error prone that you may have. And all these powered code assistants also adds more efficiency and pace to our developments. Now, if we look to these super cycle, we all know that there are some limitations. However, I will go through some limitations, but all of them are already going or tackled within the days or weeks that we're talking about. One of the limitations that is mentioned in different papers is that our system, or our brain system, has two types of decision making. One, what we call system one, which is basically how we quickly can decide in a very automatic, with no, let's say, decision-making approach. So this is what we call system one thinking. Versus the system two, it is more complex decision, more logical, you need more time. And this is very well described in the book, Thinking Fast and Slow. Now, if we look to LLM or whatever it's happening like GPT-like, we are exactly tackling the system one. So we are exactly doing what, or replacing, or what our brain is doing in terms on within the system one, so very emotional, automatic results, with what we call inference, all calls. However, we are still not there for the system two, or the thinking approach. The second part of, or the second limitation of language model is that if we know how it was built, so basically language model was a very big, we take everything that we can find on the internet, so thousands of books, Wikipedia, whatever we can get, and then we ingest this in a very, very large model and we train it for months. However, our world, our real world, is not only the reflection of what is in the internet. The internet can reflect a good part of our lives, but not all of it. So whatever is not there, then it is not understood and it's not processed, and then it is not seen in our LLM inference and calls. And this is why we say the world is not only text and images. ChatGPT, the first version, worked only with text. GPT-4 now is also digesting images. We have also audio coming, and you have seen some of the videos like this. But this is still not the real world. So, and I can insist even more, if I make maybe a projection to Africa, our language model will only reflect whatever is in terms of data related to Africa. So if there's no data, we won't be able to have efficient language model for our African problems. Maybe the third, and I don't think it's really a limitation, but it's how basically narrowed right now is our usage of a language model. So I guess everyone used GPT, right? Can you raise your hand if you haven't? Great. So it was the fastest product to go to reach that much number of users in a very limited amount of time. But everything like GPT and others are very like Oracle system, means I ask for information, advice, prediction, assistance. But this is not the only type of task that we need as users. So we have now a way to write email from scratch. We can see a lot of tools that now have their AI plugins, so they assist you in your tasks. But we need much more than that. In the real world, or let's say our whatever task we can see in the real world, is really above just oracles that might be sometimes not true. And I haven't gone through the hallucination that is also another problem that we have with language models. Yeah. So these limitations, as I said, are tackled right now. They are not completely forgotten, and there are steps and baby steps for each one of them. And for some of them, there are some debates. I won't go through the, how dangerous could be the language model and so on, but it is something that is in the mind of most of the researchers and AI thinkers. However, right now, AI is exploding much more than what we thought it would be. So if we look to what we think that AI is only GPT for like assistant or oracles, no, there are already new versions where we have basically agents. What I mean here, so if you look to the example of AutoGPT, AutoGPT is not just assist you. AutoGPT is a way where you can give him an important task and he will act on your behalf. So he will not only just answer your question or your query, but he will have a sequence of tasks. And on behalf of you, the agent will act, will memorize, will have a critical thinking about his decisions, go back and beyond. For example, it can decide if you would like him to develop, if you'd like it to develop, for example, a website, it will go to the website, it will go to the different libraries, download them, install them, write the code on your behalf, deploy it on the web, and here you go. This is one very small example of what we believe would be the smart AI or the agents, the AI agents will be able to do. And it's a lot about recursivity, means there's tasks and then they go back to the main task and then they do it in a very sequential and a very organized manner, like we would do ourselves when we have a project and then we submit it in different milestones. The second limitation I have talked about was that we believe that language models are only about text and image. But these are one of the recent papers from Google. So the model is called PalmE. And here, PalmE, what we see right here is a robot that had embedded a large language model. But the robot, basically, this language model, is not to produce text or image, is to produce actions on the real world. And this is where is this multimodality that we thought that would be one of the limitations of language model, but it's not there anymore. We are going towards this. We're going towards a sequential planning of actions where we basically, those models will have an impact on the real world. So for example, the robot will really push and then push, let's say, a box from place to another and then get some feedback and improve it. And another example, and this is one of the projects we develop in collaboration with Deutsche Bahn, the German railway company, where we develop a way where we have an autonomous manner to schedule all the trains in Germany in a very coordinated manner. So we would have as much agents as trains that we have, and those trained will have to sync and to coordinate themselves in order to satisfy the demand under all the physical constraints that we may have. So some piece of what we believe or piece of advice on how we can find ourselves or how can we find our place if we are an AI-first company. The field is really very exciting right now, but also there are some gaps that we have seen. So imagine today we would like to compete with OpenAI or Meta and develop our own, let's say, GPT-like model. This could be hard, because there is a massive amount of compute behind it and a massive amount of talented researchers who worked on this month. And so one of the ways that we can see right now, if you would like really to be a successful organization using AI, is to really work on your competitive strength, on your exact expertise, where you master the data, you understand it. You have the knowledge and the business expertise within your team for 10 or 20 years. And based on that, you will be able to have an end-to-end development of your tools, where it can work on your operations, it can work on your industrial domain, or it can even simulate the real life. And all this is really possible, and you will really have a competitive advantage because you're really master your business expertise, and what you know from your country and your field is much more than what can, let's say, OpenAI or ChatGPT would know. So there is no, here you will be competitive. So if I go back a little bit more in detail and how we see it, the data part is something you need to master. How to clean it, to gather it, to integrate it. This is something ideally should be done end-to-end on your side. Again, whenever you have this data, what are the AI algorithms and what is the infrastructure that you need to develop is also, again, something that ideally should be mastered in-house, so that at least when you are developing your product, you are able really to scale on a piece of the market, on a field where no one can compete with you. One of the examples that Karim likes a lot, so I will use the same. So it's Tesla, for example. It's one of the unique companies where they basically internalize the whole chain. So from end to end, from the hardware side to the software side, this is absolutely key and shown that this is one of the factors that made them successful in what they're doing. So imagine you are able to master all the pieces of your product from the beginning till the end. You have your competitive advantage and you are able to move and to pivot in a very flexible and fast way. However, I think we have to be very clear. If we don't move right now, the gap will be bigger and bigger. And the gap is already very big. And one of the big reasons of this huge gap is the compute, as I said again. We know how much compute is owned by the big names like Microsoft or Meta or OpenAI, and how much compute is needed to have those type of models, we know that it will be very difficult for us to catch the train. And the faster we do it, the better it is, because time is against us, because we don't have all this. And this is valid for most of the businesses and most of the ecosystems in Africa, unfortunately. So the lack of compute is something that will be very difficult to catch up unless they have massive investments here. So to conclude, I think the super cycle and the exponential trend that AI is bringing to our real life is there. We're just living it and going through it. However, it's very important if you would like to have, for your startup and for your business, to make sure that you embed any AI intelligence in your tool as soon as possible and be able to master the end-to-end chain so that you still keep your competitive advantage regardless of the field you are working on. And thank you.
Thank you very much. Thank you again. Did you
good?
see me? I was stuck behind the curtains. They're too long. You never see the end of them. Thank you again. Great talk. I will improvise one or two questions. Can we have one or two questions from the audience? There you go. Okay. All right.
Hello. Thank you for your great talk. I have a question. What are your thoughts about the fact that LLMs has to be embedded in the real world? Like, I think it's some ideas from Yann Lequin saying that just text and images are not enough, and we have to embed them in real world. Yeah, I would like to hear your thoughts about that.
I think if we are, so it depends on your field. Some of the fields can be enough with just the classic LLM. So text and images can handle most of the classic software is doing right now, because those classic softwares were only also handling those type of only data set. However, if we go to more industry level, you go, for example, to robot systems. If you would like to, put AI, for example, in big warehouses and stuff like this, you need definitely to have those embedded, it can be sensors, it can be information about, how their action is doing on the ground and so on. This is key to make sure that your LLM is really producing an efficient action. And efficient not only because it's doing it right, but it's doing it without a huge cost. So at least your trade-off from a business perspective makes sense, because you don't want also to pay a lot of money for just a very simple task.
Hi, thank you for the great presentation. You mentioned vertical integration of all the components of the value chain, like for instance in Tesla. How do you see it going forward for Instadeep?
So far, we're placing ourselves really on the software side. So for us, we are basically delivering AI value for the projects and the problems that we have to face, either within BioNTech after the acquisition, but also on any external projects. For us, this is still there, valid. However, when we have one of, for example, the products where it's more about hardware design, this is where we may explore the fact of going a little bit beyond, where we will combine either the hardware and also the software part.
Thank you.
Thank you for the nice talk. So you talked about the future of AI agents. And my question is, how easy is to reverse engineer AI agents?
What would you mean by reverse engineering?
I mean, like you mentioned that startups could work on specialized or specific AI agents, and so other people use it as a service. And my question is it really easy if we deploy publicly AI agents? Is it easy to reverse engineering it?
So I would say it would be possible, but I'm afraid that whatever will be available publicly, so it depends what, for example, if you look, for example, to the open source, for example, agents versus whatever is closed or where you have, there's a paywall, there's still a gap, right? But the good thing is that this gap is not that much. So maybe we're talking about 6-month, 12-month gap in order to get the same improvement. So basically, this is something that is manageable right now. Not sure how long this will remain. One of the good things in AI is the open source community is very strong and there's very smart things published regularly. Hopefully, this will keep like this.
Hello, my name is Ghassan. I'm a CEO and co-founder of startup BeMove. We connect parking to mobility. My question is regarding what you talked about, the force or the need of computing power. Does that mean that AI wouldn't work with a decentralized requirement for blockchain solutions? And at the same time, does it also mean that AI components won't be really efficient in edge computing-based solutions? Thank you.
When I mentioned the importance of compute is mainly if you would like to train from scratch your agent for your exact needs. This is where for us right now, I mean, when we see the gap, how much compute would be needed, it will be very difficult. And it will need a massive amount. However, if you already there's models and then you can work on the fine-tuning approach that are there, this then can be manageable because you would only need some inference calls. And this won't require a lot of I mean, it does require, you know that. But still, it's still decent and you can do it in a decentralized manner. You can do it on embedded systems and so on. The main challenge is engage in your business. You have this big challenge to have the need to train from scratch. I mean, to do something like the GPT engine. And this would be very, very difficult.
Hi, thank you. My name is Andre. I am one of the partners at Modus Africa. We invest in deep tech in Africa. Less technical question. Many investors have a perception that Africa lacks data, infrastructure. I'm curious to know, even tech capacity. I'm curious to know your point of view of the current status and what direction Africa is going as a continent.
I think it's true. And this is what we hear from startup founders. So we've been at Indaba, Ghana in September. So this is the biggest AI community or gathering for AI researchers. And there are also a lot of startups in AI usually are founded by AI researchers who find an idea and would like to develop it. One of the big challenges are how to find compute and where to find, and talking about really countries and sometimes areas in Africa. So this is one. And it can be even more local. So even in Tunisia, it's very challenging for startups to have compute locally. So of course, we still can buy credits online, but this is also very expensive. And we have specificity in Tunisia where we don't have access normally to foreign currency and so on and so on. And even before looking to the startups, our research and AI research cannot get developed without those compute. It's like we're saying to an AI researcher, try to work, but without a laptop. And this is exactly, unfortunately, what is going on. So how we would like this AI research field to grow in order to feed the AI startup. If at the beginning, the first asset is unfortunately very rare, almost not present in our countries.
We have a last question here from another one. It was answered? Are you sure?
Yes, it is basically about what keeps some of us awake at night, which is how to create computing power in Africa, because we have the brains in your three exponential things. The brains for the models, we have the data, but the computing power is a serious thing that governments and us needs to really crack somehow. Okay, thanks.
Thank you.
Thanks, Wasim. Thanks, everyone.
Thank you, Dr.